Hi everyone, we are from ES4-GROUP3 gonna present about flat survival product with Desmos. Here is our final product. Let's continue with the presentation. Let's go.
Here we will explain ton and cost graph in our design. So here is ton graph. Here is a 0.9x plus 5 minus 3. 0.9 means it width, plus 5 means it is shifted horizontally, and the minus 3 is vertically shifted. Here is a tan inverse graph. Here is a cos x graph. Okay, here is a cos 2x graph. 2 means the width. So here you can see 0.9x plus 5 minus 3. And here is a cos inverse graph. So here is our design for the front view. So here we have 0.53 cos. Okay, this one. So I will explain about it. So 0.53 means okay, where is it? So 0.53 means its amplitude. How far up does it go? And 0.7 and 5 here is width. Is width. So minus 5.5 means it is shifted with downwards. Alright, so here we can see also negative cos 0.785. So here negative cos in front, the negative means it is inverted at x-axis. Here we can see also negative tan inverse. Okay, why is it straight? It's because the curvature is somewhere around the x curve, the x-axis sorry. And then all of these are cut because we have the range.
So I'm going to explain about log graph and negative log graph, which is +1 inside the box. Inside the brackets represent the vertical asymptote, which is it -1. And meanwhile for the +1 outside the way the graph shifted, here's the difference between log and negative log graph. Now I will move on to the quadratic graph, which is this. Okay, +1 represent the y-intercept, and we can find the midpoint here using vertex form or find the root using a calculator. Okay, so I move on to our Desmos. Here is our overview product, which is inflatable boat. Next, I'm gonna explain to you guys from the plane view, which is this. Okay, I'll take the equation from this, which is the negative log 1. Yes, and the polynomial in vertex form, which is this. Okay, so I'm going to show to you guys the calculation, which is this. Here is the equation. We know that -8 and 12.5 is represent the midpoint. So yeah, here's the overview and the solution. Now we move on to log graph, which is y negative log, and we know that x-intercept is 103, -103, and y-intercept and undefined. The domain is -8, -3. Vertical asymptote is limit that not defined, which is x -3, and no horizontal asymptote. And here's the difference between negative log and positive log. So here's the solution, and we move on to Desmos back. And yeah, this is for the polynomial, and this one is for negative log to make this product. I think that's all from me.
Hi guys, so for the last part I'm going to explain about surd graph and sine graph. First of all, we need to know the basic about surd graph. This is how we search for the minimum point. We need to find the x and y. So for the x point, we need inside the surd, we need to equal it with 0, and the x will determine the x point. Meanwhile, the constant will determine the y point. And the shape of the graph will determine on what the symbol is positioned. As you can see here, the negative is in front of the x inside the surd. Thus, this is the shape. Let's see the Desmos. So it will look like this. Right here in our actual side view, the graph is positioned here, and this is the actual graph, and it has a range from 2 to 3. Okay, so for the last part is sine graph. So for sine graph, first we need to know that we are using the inverse sine. So this is the general form. And for the properties, in front of the sine is the amplitude, in front of the x is the period, next to it is the phase shift, lastly is the vertical shift. So let's see our example. So for this one, this is the graph. So inverse sine graph, and it is shifted to the right by 5 units, and -4 is the vertical shift, as we can see here. Okay, so for the negative, if we have a negative sign in front of it, it will be mirrored on the y-axis. So let's see on our actual graph. So the side view, and this is our example, these two.
I think that's all from us. Thank you.